Regina Sailing family and friends, I hope you've enjoyed the tutorial. We're going step by step further now, doing the planning of the twilight shooting. So we have come this far, 26th of February, we have our approximate positions and we have calculated at what times we can shoot in the morning and what times we can shoot in the evenings. So ideally we shoot in the morning at about 6:58 or call it 7 o'clock, and then a little bit before that and a little bit after that. If you want, you can take the middle of these two times and start shooting there, and take the middle of these two times and finish shooting there. But I wouldn't be that strict. I mean, as long as you can see the horizon and as long as you can see the bodies at the same time, I would go for it. So maybe when it's still very dark, when you just can see the faint horizon, you could start with shooting the faint stars, and the more light it gets here, the better you can see the horizon, and in the end you can just see some very bright stars or maybe planets. And the same in the reverse here in the evening. So now we come to this part of my template. So we know when it's sunrise. So we get that time from here. So sunrise is 7:23. It's the same for all the planets, Venus, Mars, Jupiter and Saturn. And here we have the numbers in which priority. So we should try to shoot Venus in first place, then Jupiter, then Saturn and Mars, in that order of the numbers, because they are that's the number of brightness that they have. And the sunset here, that comes from here, it's 1843. That's valid, of course, for all the planets just over here. Now we'll see how much ahead or how much behind these planets are. So for this sake, let's look at this frightening diagram here. But if you've understood it, you can yourself look very cool. So if you remember from the tutorial, we have the months here, January, February, March, April, May, in this direction on the x-axis. And here we have the times, and at noon, that is what happens. That is 12 o'clock at the meridian at Greenwich. So the sun passes in January, February, March, April, May, June, and so on, all the way to December at around 12 o'clock, the meridian. Now, not quite always. So here, if you're really looking very exactly on that, you can see here that the sun is actually a little bit running behind in the early months. And here, in this year, in the late months, it's going a little bit early up in October, November. So let's double check that, just because we are interested in seeing if we had done our homework correctly. So according to this, the sun is a little bit later than 12 o'clock on the 26th of February. The 26th of February is here. And if you look at the meridian passage there, you can see that it is actually at 12:13, so a little bit later. The sun is a little bit later than 12 o'clock at the meridian. And that is exactly what this chart is showing. So here we are. So 26th of February, I'll make a line here. That's here, there. So we know that the sun is a little bit after 12 o'clock. All right, never mind the sun, because we can't shoot any planets in this shaded area anyway, because it's too bright, they're too close to the sun. But we have something here, that is the Venus. So Venus is about at 3 o'clock here, so it is running behind 3 hours. And when we look down here, we have Jupiter down there and Saturn over here. So Saturn is maybe not so popular, but Jupiter would be good. So Jupiter is over here. So it is at 9 o'clock. So it's 3 hours before 12 o'clock. And down here we have Mars. Mars is on the fourth priority. So maybe we don't choose that. We choose two planets. So that's quite cool, isn't it? So that means that the Venus is here at 15 o'clock, so it's 3 hours later. So 3 hours later. So So the Venus is up here. You can see that I have a little memory here. So there. So these are evening planets, and these, which when they run early, they're morning planets. So the Venus is 3 hours on the top side, so that's an evening planet. That's a perfect evening planet. So that's why I write it here in the red box. It's behind. So Venus here is 3 hours behind. And then we said that Jupiter, that's that line, is at here exactly at 9 o'clock. I'll show it to you. There. Where are you? At 9 o'clock. So that means that it is 3 hours before the Sun. So you can write here Jupiter, and that is on the lower side. So that's why it's in the early morning here. So 3 hours here as well. So that means that it sets the Venus sets 3 hours after 1843. This is only for you to get a grasp of which planets you want to have. So you could write here 2143. So that's when Venus sets. So you can just have a look some minutes before 2143 at our latitude here, and then we can see Venus disappearing. And in the morning it's running 3 hours ahead. So we can say it's actually for the Jupiter 423. So if you go up early in the morning and you have a watch at that time, maybe you could see the Jupiter rise ahead of the Sun at 4:23. Then it comes up beautifully, and 3 hours thereafter the Sun should come up. So let's go on this side of the template to decide which planets do we want to use. So first of all, I copy the civil twilight because that's such an important time, because that's the best time to shoot. So that's very good. And the same here, 1909, that's the best time to shoot in the evening. So which planets would we choose in the morning and which planets would we choose in the evening? Well, we take a blue planet here. Here it is, it's the Jupiter. So I'll write Jupiter here. We don't take a second planet because we haven't got one here. And in the evening, we would choose the Venus. Venus, and no second planet. So now comes the approximate calculations of declination, Greenwich hour angle, increments, and then the total Greenwich hour angle, and our chosen longitude. Approximate means, so we talk about full degrees only for this time approximate, because we don't know exactly when we're going to shoot. It's only for planning. And the planning goes like this. We want to find a local hour angle, because if we have a local hour angle, we can go into the site reduction table and find the calculated angle HC, or altitude HC, which we should be able to see Jupiter. And you can also find the azimuth in which direction we should see the Jupiter. So if we look into the direction of the azimuth towards the Jupiter, use the hand bearing compass, and preset the sextant at HC approximately, and at 7 o'clock approximately, you should see something there, a bright something, a star, or most probably the Jupiter planet, either just above or just under the horizon. And when we have found it, we can then shoot it precisely. But that's an exercise for doing this on deck around 7 o'clock in the morning. So this is just the preparation for the same. And the same is valid here at Venus. We will find its declination and so on to find the preset altitudes and azimuth. So for this reason, we just go from the top to the bottom and work ourselves through. So it's not so difficult as it seems. So we find the approximate declination of Jupiter at 6:58. So we take the 26th of February, which is here, 26th of February. We take the Jupiter. We look here, down here, 26 at approximately 7 o'clock. So we take 7 o'clock there. So we see that the approximate declination is south 22 degrees and 6.7 minutes. We can do a double check. It doesn't change much before, it doesn't change much after. So let's call it 22 degrees and 7 minutes. And we can also just check the Greenwich hour angle, which says here for the Jupiter at the full hours of 6 o'clock. So that is 315 degrees and approximately 9 minutes. Here we can't do an eyeball navigation really, because the next figure is 15 degrees further on, which is no surprise because in 1 hour it goes 15 degrees. That's the standard increment because of the turning of the Earth around itself. So let's take it at the full hour. That's 315 degrees and 9 minutes, not to forget the declination there. So let's write this down. So we have here south 22 degrees and 7 minutes. The approximate Greenwich hour angle is 315 degrees and 9 minutes. The increments from 6 to 6:58, these 58 minutes, they should be around just under 15 minutes. So we'll look at the increments here for 58 minutes. That's here. We don't know about the seconds because we don't have to be so exact. So it doesn't really matter what we choose here. So let's take 58 flat. So 58 flat and 0 seconds, that's 14:30 there. So we write 14 degrees and 30 minutes there. So the total Greenwich hour angle, if we add these together, is 329 degrees and, well, 39 here. Well, we can take 39, it doesn't really matter, because the chosen longitude will be in vicinity of 11 degrees and 56 minutes anyway. So we need to have some 39 in the end there. Since it's westerly longitude, we deduct them. So we will make 11 degrees here. This makes 0 minutes. That's exactly the idea of local hour angle. And here we deduct these, so it becomes 318 degrees. So the local hour angle is 318 degrees. We do the same for Venus. What is the approximate declination of Venus on the 26th of February? Here Venus comes first. I don't know if you know that. These figures behind Venus here, that's the brightness. So the smaller the number, the brighter it is. So Venus is really bright here, minus 4.3. Mars is not so bright. It has even a positive number there. So Venus has a... there we have now to look at in the evening, of course, because we're shooting it in the evening. I've already made a line there at 19 o'clock. So the Greenwich hour angle, the declination is north 9 degrees and some, well, call it 18 minutes. And the Greenwich hour angle is 61 degrees and, well, what shall we say? Say some 61 degrees and for the full hour, 14 minutes. So we write here 9 degrees and 18 minutes north. And at full hour we had 61 degrees, let me check again, and 14 minutes. So the increment for the 9 minutes, we'll look down here, back here, 9 minutes, it's here. Well, if we say 0 seconds, it's 2 degrees and 15 minutes. 2 degrees and 15 minutes. We add those two, so that becomes 9:29, and this is 63. So we have 63.29 here. We choose our longitude. Well, the longitude is approximately 13 here in the evening. So let's call it 13 degrees and 29, just so it becomes 0. So that means 0 degrees, and this becomes then 50, like this, 50 minutes, 15 degrees. So the greenish hour angle is 50 degrees. So let's now look into the sight reduction table to find the declination of 22 degrees. It's contrary because the Jupiter is in the southern hemisphere, we are on the northern hemisphere. We go into a latitude which is close to 36.47, let's call it 37 degrees, and then quickly look up what HC and what Z it would be. So I've got the corresponding page here. It is contrary, it is in the right range, and we have the latitude 37 degrees there. So now let's look what we have. We have a declination of Jupiter of 22.7, so that's here, and we have a local hour angle of 318. So 318 is in the middle row there. So if we go from the middle row there, we go over, middle row there, so we go over until we get to 22 here. So we can see that it's 18 degrees and 57 on the sextant. Never mind this D factor, we'll do that when we do it precisely. And it has an azimuth of some 339, or a Z of 139. So let's copy these figures. So we have an altitude of 18 degrees and 57 minutes on the sextant that we should see, and a Z of what did I say? 139 degrees. Now, if the local hour angle is larger than 180, then this is the azimuth. So yes, this is the azimuth. So we know the direction of the Jupiter, and we know what to put the sextant, set the sextant on. So we'll look at Venus. So Venus, in the evening, we are at 35.25 north, so that is close to 35 degrees north. So we take the page of latitude 35. It is, the Venus is on the northern hemisphere, so are we, so we take the same, and it has a declination of 9, so it's the same range, so it is about here. So make an arrow here for the declination 9 and the local hour angle of 50. So let's find 50 here. 50, it's over here. So if we now go on 50, that's the top line there, go over here to get the corresponding declination. It's over here. So that's where we are. So the figures here are 37 degrees and 34, and the Z is 107. So I copy that. Yes, 37 degrees. It's difficult to get wrong in the lines, so I have to double check that. 37 degrees and 34 on the sextant, and the Z was 107. Now the local hour angle is here smaller than 180, so that means that we have to take 360 degrees minus the Z 107, so that makes it 253 degrees. So in the direction of 253 degrees at an altitude of 37 degrees and 34 minutes, I preset that on the sextant, we should be able to shoot the Venus. So now we've done this preparation for the morning and the evening when it comes to the planets. So we could actually go up on deck and shoot this in the morning, but it is so much more fun to also pick up some stars. So we'll prepare for the stars in the next chapter.